Hello, welcome back. We're going to look at bubble sort now. We start off with an example as usual, and then we write the algorithm and we analyze its running time. So let's start with an example. Uh, okay, so this is an example, and we're going to do the bubble sort, right? And the idea of bubble sort is that it's going to go through the array like this, left to right, and it's going to swap any two numbers which it sees are not in order. So first, it's going to look at the first two, right? These two numbers, are they in order? No. You want to swap 10 and 15, right? So that's what it's done now. Okay. Next, it looks at these two numbers, 15 and 23. Are they in order? They are in order. So no need to swap. Good. What about 5 and 23? They are in order? No, they are not in order. So you swap 5 and 23. Okay. What about next 17 and 23? They are also not in order. So you swap 17 and 23. Two and 23, you swap again. 2. 23 and 12, not in order. So you swap again. Okay. So this is one pass of the bubble sort algorithm, right? And so this is one. So let me just note down. So one pass of bubble sort, and what happened after one pass of bubble sort? Okay, what happened is that, as you could notice, is that we did lot of swaps, but we also ensured that the maximum comes to the end of the list. Okay, so the maximum element appears at last position. That is an observation of that's a consequence of the bubble sort algorithm, right? Consequence of one pass of the bubble sort algorithm. So this is the maximum element. So now I know that I don't have to. So I'm going to repeat the same bubble sort procedure again and again, right? Until the entire array gets sorted. This is what I'm going to do. Uh, okay. So then the next bubble sort. So the next, sorry, in the next pass of this algorithm, we don't have to go through the entire array because we already know that the last element is the maximum. So we are going to go do it only till here. Okay, we are going to do this pass only till this much from here to here, and we follow the same procedure. Okay, the next pass we are going to look at again. We are going to look at the first two numbers, and we swap if they are not in order, and we don't swap if they are in order. So 10, 15, are they in order? They are in order, so no need to swap. Next we go to 15, 5, are they in order? No, they are not in order, so we swap. 17 and 15, are they in order? Yes, they are in order, so we don't do anything. 2 and 17, are they in order? No, they are not in order, so we swap. 12, 17, are they in order? No, so swap. 17, 23, are they in order? Yes, they are in order, so done. This is the second pass. So in second pass, what happened? The second largest element came to this point. Okay, sorry, we did an unnecessary step of, we don't have to look at 723, okay, because we had to consider only till this much. This is already 23 is already the maximum, so we are not going to go look at it right after the first pass. Okay, so now we have the situation where the second largest element is in the second maximum position. Okay, it's here. So now we are going to look at the array till only this much, this point. okay, and we again do this, uh, we, we apply this bubble sort procedure, okay, once more, but only till this much, only till array here till here, okay. So 5 and again the third pass now, 5 and 15, sorry, 10 and 5, are they in order? No, they are not in order, so we swap. 10 and 15, are they in order? They are in order, so nothing to do. 15 and 2, are they in order? They are not in order, so we swap. 15 and 12, no, they are not in order, so we swap again. Done. The third pass is also over. Again, the 15 has now come to 15, which was the maximum among these numbers, have come, and it has now bubbled up to this position. Okay, which is where it should be in the final output, right? So now again, we need to now consider only this much of the array, and that's what we are going to do again. We are going to apply the bubble sort procedure again, and so 5 and 10, they are in order, fine. 2 and 10, they are not in order, so let's swap it. 10 and 12, they are in order, so it's fine again. So we have now reached, we have to now do bubble sort here in this array. Okay, 2 and 5, are they in order? No, they are not in order, so just swap again. 5 and 10, are they in order? Yes, they are in order, so nothing to do. So we have now reached this much. We see 2 and 5, are they in order? Yes, they are not, and we are done. So this is bubble sort. We are now going to write this algorithm. Okay. First, we need to decide how long should we do this, keep on doing this bubble sort, right? So how many times? So every iteration of the, after the first pass of the bubbling, what did we get? We got we got the maximum at the last position. The second pass of the bubbling, we got the second largest position in the second last position, right? And the third pass, we got the third largest element in the third last position. So it goes on like that. So how many passes should we do, right? We have to do n passes because there are n elements, right? Okay, so that's the first thing we are going to do. We are just going to do n passes. So we are going to do n passes. Let's just look at the first pass. Okay, so which is now I is equal to 0. The first pass, what is it we have to do? We have to go through the entire array, right, and swap whenever the order is not maintained. So I'm going to do that right now. So for that, I'm going to write j is equal to, what should j do? J has to go from 0 to, till what position should j do? So j only has to go till, okay, only till n minus I, actually minus 1. Okay, because in the first pass it has to go till the end, in the second pass it has to go till only the second last position, and third pass third last position, etc. So that is why there is this n minus I, and minus 1 is there because I'm going to consider 2 consecutive positions. So let me write that thing. Right, so there is this j plus 1 I am using. So AR of 0 and AR of 1 I consider, I compare first, and if AR 0 is greater than AR of 1, we do a swap. Fine, yeah. That's all. We just keep on doing this for n times, and we are done with bubble sort. Okay, so whenever there is the order is different, we swap. Right. Okay, now this is fine, and let's try to analyze its running time. What is the worst case running time of this? The worst case running time of this is n minus I plus 1, right? And in the beginning I is 0, so this is n minus 1, so it takes n minus 1 this block. Second time this block is executed, it's going to take n minus 1 plus 1, n minus 1 minus 1. Okay, third time is n minus 2 minus 1, etc., etc., until 1. So what is this? This we know is again O of n square. Right. So running time of bubble sort is again O of n square. Okay. Right. Now let's look at this bubble sort algorithm, and we will make a small modification to make it better, at least in the best. So in the worst case it's O of n squared no matter what happens, but we can make it a little better in the sense that in the best case it's going to work better. Okay, so in the best case scenario also bubble sort is going to, so this implementation is going to take O of n squared, and let's look at let's look at one case where it's just taking O of n square and it should not be taken. We can improve on the bubble sort. So let's consider the following numbers. So it's actually the numbers are in sorted order. So let's say 10, 15, 20. So the numbers are in sorted order. So the bubble sort is now going to go through. Okay, so it's going to start with I equal to 0 here, right? And it goes inside and it goes to the, so it goes through the entire thing, and in the first pass it goes through the entire array and without making any swap, right? And okay, because it's all in order, so it's not going to make any swap. Again it goes here again in the second time, I is equal to 2, and it again goes through the entire array without making any swap. Third again it's going to do this thing, right? And what is the point? It's not doing anything, it's just going through the array multiple times without making any swap. So therefore it took O of n square. But there is a better idea. What is the better idea? The better idea is that once I see that no swap has been done, what is it I can do? I don't have to go through the outer for loop again. Once I know that there is no more swaps to be done, it means that the sorting is completed. The array has finished sorting. So in that case, I just have to say done, I am done, right? So I can implement that by maybe putting a flag here, which let's okay. So the flag I set to false, and inside swap I'm going to put, right, the flag is set to true. So if swap happens, the flag is set to true. Okay, and then I come out of the for loop. Okay, so this is right. This is this for loop bracket, and I come out of this for loop and I check whether the flag is true. If the flag is true, I mean, if the flag is still false, if the flag is false, it means that the swap never happened, right? So I just check that flag. So if the flag is false, I break out of this for loop. Okay, so if the flag is false, it means that this no swap happened, and in that case I just break out of this for loop. So now let's look at this example. So 10 okay, so we are in I is equal to 0. I just come here, we go through this entire J loop. So one pass we make over this entire array, and the flag was never set to true. The flag remains false. So we come out and we see that the flag is false, and then we break. Okay, so in this case, what is the running time? what is the running time of this algorithm in this case? The running time is going to be just execution of this one for loop and not the outer for loop, and therefore its running time is order of n. Okay, so this is the best case running time, best case scenario, and the worst cases. Okay, the worst case is still of n square. And what is an example of a worst case? Okay, the array is sorted in the other order. Okay, if the array is sorted in the other order, you're going to see that. That means it's, so 30 is first, it's in descending order, the array is in descending order, and this sort, our implementation of sort is to sort the array into ascending order. Thank you.